Greetings, I am Surat, this is Shah, and we are presenting our project, iCoach, an AI-based multi-platform audio-visual feedback application for exercise. So this is our project concept. So we all know that exercise is a powerful mind-body practice for well-being, yet if done improperly can lead to chronic pains and injuries. Also, often we cannot see our progress and get demotivated. So the question was, can we create an AI-based audio-visual feedback application that is freely accessible to people through multiple platforms that can help them to exercise safely?
So we did a research of existing solutions. So there was one solution by Sinha, but that required to upload a photo to on the web and then compare it with the poses of expert. This is a problem, one, because you don't get instantaneous feedback, and two, because it's compared with the pose of the expert. So it is very demotivating for beginners to see that they're not doing the exercise well and there's no feedback for them to do it better. And the other one required Microsoft Kinect, which is a very expensive 3D mapping tool. So the existing solutions were licensed, they were expensive, they used high resources, and there were compatibility issues. And most of all, they were not easily accessible to everybody. So our objective was to develop a low-cost, open source, low resource use soft feedback solution for monitoring exercise. So to do this, so this is an overview of our algorithm. We take in the user's landmarks from the camera, and then we extract the landmarks, and then we classify the pose using our own decision trees, and then we assess whether the pose performed is good or not by using a k-means clustering algorithm, which I'll come to in later. And we also monitor thresholds in a parallel loop, so that if the user is incorrectly performing asan or he's going towards injury, it can give off alarms. So first we collect a questionnaire to assess whether the user is old, young, pregnant or not pregnant, whether they're elderly or disabled. And we extract landmarks using PoseNet and MediaPipe or MediaPipe. We can use both one at a time. And this is a post classifier. Now, we wanted to make a system that was dynamic and that would include more asins. So we made our own algorithms to extend our existing machine learning pipeline. So one algorithm we developed was to include an altogether new type of class of asins in a single go. So to this, we do not touch the existing model, but we train another model on the new data, and then we only take one more decision to distinguish between which model to run. And existing solutions by Google's neural network is that they train the whole model on the whole new data set. And we'll show our results later. This makes our solution extremely fast. And the other is if you want to add an exercise to an existing model, So what we do is we run the existing model on it, and when it incorrectly classifies it, then we just train one node to distinguish it between the correct and the incorrect class, which is the new one. By using the new algorithms, we are 384 times faster than Google, and 72 times in training, and 72 times faster in running. But the problem was that our accuracy dropped. But our goal was not to train it once and then run it on every user, because then it doesn't adapt to users. Our goal was to train it on every user. But because our training time is so fast and it is so low resource usage, we can train it live on everybody. And that increases our accuracy to 94, which is really comparable. And here you can see the graphs. Next is post feedback. So we create a fuzzy cluster around the perfect joint angles, and then we create the clusters around it. And then using fuzzy clustering and value gauging, we can calculate how much the user is performing the asan correctly and how wrong they're performing, and then you can perform feedback. Here, like I have moved away from my cluster, so it's giving me a warning to please move into the frame. Compatibility. So it is compatible. We have tested our application on Linux, Windows, and FreeBSD, and on macOS there is partial support for it. And also we have tested on it extremely low cost compute hardware like a Raspberry Pi 3 and 4, which is a 2,000 or 4,000 rupees small computer. So we can also deploy this in poor and small villages, and they do not need to buy any new expensive hardware. A friend of the mother of a friend of ours works in a professional athlete training lab, and to develop a similar system, they use 1.5 crore full body sensors. So our doesn't require any new thing. It just requires a free software which you have to download and run on any system, and it can run on phones, laptops, and on small devices. And it is also compatible with users. It can adapt to elderly people, people with disabilities, because you're live training out in everybody, and people wanting to coach themselves on different exercises. And also, like, if people want to use our program for other use cases, like to count their repetition, count the reps of their exercise, they can also use this. Like, we can modify our program to adapt to different kinds of use cases. So we believe in free and open source software. So our software is completely free for us to run because it does not require any server. It runs completely on the edge, which gives us the added benefit of requiring no internet, and which ensures complete privacy. Because if you're performing exercises, you cannot have your videos leaked over the internet, and it is scalable from 100 users to 10 lakh or any without zero cost to us. And feasibility in the current market. The market is ripe for self-training tools and remote monitoring, especially with the arrival of gym decentralization. So let me give you testimonial. So Ministry of Education in a hackathon, they sponsored us to develop this further, and AWS also invited us to a networking event where FitPass and Ahamyo contacted us. So FitPass is a gym decentralization. So what they do is they they have a pass for every gym which you can use to go into every gym. So if you're traveling to Missouri, you don't have your trainer traveling along with you, but if you can use our iCoach to train on the go. And Ahamyu is a physiotherapy company clinic which reached out to us. So they train people once a week, and they use our application to remotely monitor and to check the quality of the users perform their patients remotely. So it runs completely on the user side. It requires no new hardware, and it requires no power hungry service on the cloud. So it is essentially carbon zero. The carbon footprint is zero. And also decentralization leads to less travel, thus reducing carbon emissions. Development scope is that we can multiple users can use a single camera, which will show in the demo, and also we can use multiple devices in one. So what makes us different? So we are totally free of cost. We do not charge for usage, and we make our code open source. And there is no initial paywall barrier, no new hardware, and it does not discriminate, and it is adaptive to each user. So I'll just show you a live demo right here. Yeah. So like if they can move side, I'll show you. So I can form Yoga live, and it's giving me live feedback on whether I'm doing it good or not. Thank you.